Hi and Assalamualaikum everyone. My name is Noelisa Najawindi Zulkifli. Today I'm going to talk about Perkins tonometer. So let's go. Before we go further, let's know a little bit about what Perkins tonometer is. Perkins tonometer is one of the devices that could measure our intraocular pressure. Intraocular pressure is important to diagnose either the people have glaucoma or not. Perkins tonometer is a like Goldman tonometer, but it is designed as a handheld device. This type of tonometer is designed for people who are not able to sit upright or difficult to sit in a long time at the Goldman tonometer. For example, a person in supine position during surgery or obese person, also a children, and all folks. Perkins tonometer is categorized as applanation tonometer. Applanation tonometer is a tonometer that measures the intraocular pressure by flattening the cornea area. The intraocular pressure could be measured by knowing the force applied to flatten the cornea. Now, let's discuss how can Perkins tonometer works optically to know our intraocular pressure. There are 5 optical principles in Perkins tonometer. The first one is Imbert-Fix principle. Imbert-Fix principle, also known as Imbert-Fix law. This principle states that when a force is applied to the cornea area, the applanation is occurred. The amount of force applied to the cornea is directly proportional to the intraocular pressure. That means when the pressure in our eyes is increased, the force to flatten the cornea also will be increased. The second one is prism applanation. In the Perkins tonometer, there is a prism that will be contacted to the center of the cornea. The diameter size of the prism is depends on the patients themselves and also to the manufacturer. However, the common diameter size of the prism in the Perkins tonometer is 3.06 mm to achieve the accurate measurement of the intraocular pressure. Perkins tonometer incorporates with a system of Myers. The Myers in Perkins tonometer is visualized as concentric rings of light projected onto the cornea. These Myers are reflected back and captured by the tonometer's optical components. There are 2 types of concentric rings. The first one is outer rings and the second one is inner ring. The outer ring has a larger diameter than the inner ring. The diameter of the rings is created by the prism tip. The outer ring acts as a reference for alignment, while the inner ring acts as a reference that the tonometer is in contact with the cornea. The thickness of the rings is influenced by the amount of the eye drops applied to the patient's eye before starting the procedure. If the thickness of the rings is quite big, it means the amount of the eye drops is too much, while if the thickness of the rings is quite thin, it means the amount of the eye drops is too less. The thickness of the rings is important because the wrong thickness could lead the wrong measurement of the intraocular pressure. The next one is Purkinje image. Purkinje image are image of the light source that reflected by different surfaces on our cornea. The Myers of the Perkins tonometer appear within the Purkinje image. The Purkinje image acts as a reference point for aligning and positioning the tonometer on the cornea to achieve the consistent and accurate measurement of the intraocular pressure. The last one is alignment and displacement. Alignment and displacement is crucial to obtain an accurate intraocular pressure readings. When the cornea is flattened by the prism, the alignment and displacement of the Myers will be changed. The Myers move relative to each other and undergo changes in size and shape. To align the Myers, the inner rings should be attached to each other, ensuring the Myers is centered and concentric. This alignment facilitates a proper applanation and accurate intraocular pressure readings. To measure the intraocular pressure, it is observed based on the shapes of the Myers. If the inner rings of the Myers is touch each other, it indicates an optimum intraocular pressure. But if the inner ring of the Myers is moved towards each other like this, it means that the patient has high intraocular pressure. While if the inner ring of the Myers is moved away like this, it means that the patient has low intraocular pressure. The shapes of the curvature also can indicate if the person has astigmatism or not. And if the curvature of the ring is quite sharp, it means that the patient has astigmatism. So these are my reference list to gain information about Perkins tonometer. If you want deep and more understanding about this instrument, you can go further to the list. Okay? So before I say goodbye, thank you for your attention to listen and watch my video. So I hope that my video can give more understanding about this instrument. So goodbye everyone.